This session is actionable continuous delivery metrics. So I guess if you're expecting something else, now is the time to go. Otherwise, I'm going to get started. My name is Suzie Prince. I work for a company called ThoughtWorks, and I am the head of product in our product division. I have been working with Agile, continuous delivery, continuous integration in the product management of teams working that way, and also for software products that are created for continuous delivery for about 13 or 14 years. For the last 5 years, I've worked on 2 different continuous delivery tools. One was a SaaS-based tool, and the other is a tool called GoCD, which is an open source continuous delivery server. If you're interested about GoCD, we actually have a booth upstairs. You can come and take a look and learn more about that. My time working with those products and on those teams has meant I've spent a lot of time with teams who are embracing continuous delivery, those teams who are still really scared about moving to a quarterly release basis, to those that are deploying many, many times during the day. And so what I want to share with you today is some of the learnings from working with those teams and also the teams that I work with. I hope that I have empathy and something interesting to say to you wherever you are on that journey, your continuous delivery journey. And I think I do have time for quite a few questions at the end. So as I'm going through, if you have those questions, please remember them. I think that that might be the best way for us to learn together at the end. I'll take those questions. So just a little bit more about ThoughtWorks. If you're not familiar with ThoughtWorks, we're primarily a software consultancy. We're a bunch of technologists across the globe who basically go into organizations and help them transform their software delivery. And as well as doing that, we make products, which is where I work, and we also do a bunch of other things, literature, books, and then other open source projects. So if you're familiar with one of the first continuous integration servers, Cruise Control, that was created by a bunch of thought workers. Selenium, I'm sure if you're not using it, you'll definitely have heard of it. That was contributed and created by some of my colleagues. And then GoCD, I mentioned that. And then I assume most of you saw the keynote yesterday. Jez Humble, who spoke yesterday, wrote the book Continuous Delivery, and he was actually one of my colleagues in ThoughtWorks product division about 5 years ago. So that's kind of who we are and the kind of things that we do. So before I dive into the meat of the talk, I just want to give you a little idea of what it's going to be about so that you can follow along and decide if that's what you want to learn about today. I'm going to go over a definition of continuous delivery, and that might seem a little tedious for those of you who are familiar with it, but I actually think the way that I define continuous delivery, which is specifically from the book, actually differs sometimes when I talk to people, so I want to be clear about what I mean by continuous delivery and how I'm using that in this particular talk. I'm then going to talk to you about why it's important to measure your continuous delivery process. Then I'm going to give you some specific metrics for what you should measure and how you can measure them. And then at the end, I have some fake, real scenarios about what those metrics might look like in practice and what you might do if you see certain values for those metrics. So how you would understand what those metrics mean and what they might mean about your continuous delivery or your software process. And then, like I said, I'm definitely going to have time for questions. So first of all, a quick introduction to continuous delivery for those of you who are not familiar, and like I said, maybe a redefinition if you are. So this particular quote that I have here is taken, like I said, from Jez's website, and it's my favorite definition of continuous delivery. I'm going to read it out to you and then point out some things that I think are particularly important there. So it says, continuous delivery is the ability to get changes of all types. That includes new features, configuration changes, bug fixes, and experiments into production, or the hands of your users safely, quickly, and in a sustainable way. And it's kind of a mouthful, so when I try to remember this, I just think about it that it's all types of changes. So it's not just about new features. This is about your configuration of your continuous delivery process, and it's into the hands of users, so like delivering value into production. And then the other thing is that it's safely, quickly, and sustainable. So this isn't about killing ourselves when we put things out into production. This is about doing this process calmly, sanely, and repeatably. And what it really looks like in practice, at least for the teams that I work with and many of those that use our products, is it generally means that people have a simple continuous delivery pipeline that can look something like this very generic one. And I want to just show you what each of these things mean, because we're going to see this diagram multiple times during this talk. So each little rounded rectangle there is a stage in a continuous delivery pipeline. The blue circle at the front is the material. Normally that is a source repo, so your Git or your SVN, TFS, if that's what you're doing. Sometimes it might be an artifact, so it might be an installer from some other set of pipelines, but generally we think of this as a source repository. And the little dotted line there indicates a manual gate, and I'll talk a little bit more about that. So in this particular example, I want to show you what it looks like when somebody commits a change and what would happen in that continuous delivery pipeline. So first of all, let's imagine that someone puts a new piece of code into their source repository. The CD server will run, and first of all, it's going to run the stage build and unit tests, and that's basically a set of automated tests that test whether that code recompiles and integrates well with the rest of your software. And if those tests fail, the stage would be marked as failed, which I'm going to show as red. The team would be encouraged to immediately fix that failure and resubmit their code. And then it may move further down the pipeline, so that stage would become green, it's passing, and then it may fail further down. And again, the same things happen. Someone recommits their change, they put it into the pipeline, and this time it goes all the way through to green. And that's basically the idea of a continuous delivery pipeline, is that you continue to put software through that pipeline with increasing confidence that what you're going to put into production is actually going to behave as you expect. Like I said, in this particular example, we have a stage called a user acceptance test, and I'm modeling this to be a manual step. And basically, that's what I want to distinguish between continuous delivery and continuous deployment. In continuous delivery, we allow a human to make a decision about whether software goes to production or not. So often there will be a manual step where somebody says, hey, we're confident this is ready to go. This is the right time for us to put this into the market. This is when we want to release this to our users. So we have a manual approval. In continuous deployment, we may differ that process by allowing that product to go straight out in production if it passed all the tests. So it's a very similar process, and you get to decide which one you do. But I'm just going to use those two words interchangeably: continuous delivery, where we have a manual step, and continuous deployment, where it automatically, if it passes the pipeline, it goes out into production. And so in this case, they want it to go to production, so they send it out there. And then this process, through the life cycle of your product and your software delivery, is going to happen many, many, many times over. And it's this repetition of this process that allows us to gather metrics about the process and understand what is going on and how to measure that process. So when you see diagrams like this later on, imagine that I'm trying to say that that pipeline has repeated many times over and over, and those stages may have passed or failed at different points of time. So imagine you've got that all down and you've started to go through this process, you understand your pipeline. Why would you measure this particular process? Like, what is the benefit of measuring and gathering data about this particular process? I think there are three key reasons why you don't just want to do this, you also want to understand how you're proceeding with this particular process. The first reason is that continuous delivery is basically a continuous improvement process. It's a big, massive feedback cycle. Every time you put something in, you get feedback. Every time you run through the pipeline, you want to improve how well that pipeline is moving and how smoothly your code gets to production. And metrics really help guide your journey on this continuous improvement. If we think of something like a plan, do, check, act feedback cycle, the metrics are really a way to set specific and measurable goals. So in like the plan section, if I want to set myself a big goal, you can pick a metric for that. And then that actually helps guide your activities towards what you're doing. So you have your goal, you head towards that goal, and then you're going to check. So, oh, is my metric, does my current value for this metric match my goal? Am I heading in the right direction? So this is the main reason why metrics are really useful. They basically act as your feedback to determine whether you're improving your continuous delivery. And a good example of a metric that is used to guide continuous delivery process is deployment frequency. And this is, you'll hear this often, and I'll talk about it a little bit later on. People say, I want to deploy multiple times a day, or my business wants to be able to deliver to production once a week. That would be a great goal. You would say, okay, our goal is we want to deliver monthly, or we want to deliver weekly. You would then measure what are you actually achieving, and then you'd be able to look at your pipeline and see whether you were doing it or not, and that would be your way to check whether you were going towards that goal or not. And we'll talk more about these metrics a little bit later. So that was feedback. The second reason is that understanding the values for metrics in your continuous delivery pipeline actually gives you predictability. And this is very nice and reassuring. So once you start practicing continuous delivery, I mentioned that one of the things about the very definition of it is that it's sustainable and that it's repeatable. And so what you get is this cadence of work that is repeated. And once you have that, you actually get predictability. So you're actually able to say, okay, it takes us 6.5 days to move code from this environment to this other environment, but I know that generally that's how long it takes. So I can predict that the next time my business wants to do something, rush something out, is expecting something that maybe is unreasonable, you actually have the data to back up and say, this is actually, I can predict that we're not going to be able to do that, or we can do that. This is what we've done in the past. And that's really, depending on what those values are, it's actually quite reassuring to feel that it is repeatable and you can make some kind of prediction. The final thing, and you may be familiar with a slide similar to this from the keynote yesterday, is that if you measure your continuous delivery process, you can actually understand how you compare to other benchmarks. So this is data from the Accelerate book, and it shows the difference between high performers and low performers over 4 metrics that I'm going to talk about a little bit more later on. And if you understand your values, you can actually understand where you compare to these benchmarks. And generally, comparisons across teams and comparisons across organizations is not something that I would normally say, hey, you should benchmark yourself against Google because, that's very important to get to. But I think in the case of these type of benchmarks from the DevOps reports and the Accelerate book, they're actually very useful to help you set the goals that I talked about earlier on. So if you know that you have the ability and others have delivered with a failure rate of less than 15%, it actually lets you know, okay, we're at 18% right now, we're 25% or 35%. What goal do we want? How far do we want to get in terms of these benchmarks? And of course, the further you move to high performance and elite performers, obviously the better performance your organization is going to get. So I really recommend that you take a look at those reports and think about where you want to be and use the data that you have to understand how far there is to go, or whether it's a big pat on the back and everybody goes home because your job is done. So those are the 3 reasons why you should measure your continuous delivery process. Now I want to talk about what you should measure. And there are many options. There are so many metrics that people talk about in terms of continuous delivery. This is just a sample of some of them that I found in continuous delivery case studies, in the reports that I referred to that our clients were using, that our customers were using. And there's a whole bunch of different things here. Escaped defects, production outages, deployment frequency, the one I mentioned. And I definitely don't suggest that you start with all of these. And in fact, some of them may never be relevant for your organization. So there are 4 metrics that I would like to suggest that you use, because I think they're generally valuable and they're universally applicable, and they really do help set those goals for your continuous delivery process. And those are throughput, cycle time, mean time to recover, which is often abbreviated to MTTR, and failure rate. And I'm going to talk a little bit more about why these 4 are important and what their definitions are. You may see them described slightly differently in other literature, like on the table that I showed you earlier. I think throughput is not there. It's called deployment frequency. Bear with me on those things. The definitions change, but I will describe what I mean by these and call it whatever you want. So throughput, generally this is shown as a percentage, so the percentage of code that progressed from the beginning of your pipeline into deployment. It's normally code to deployment, but sometimes people describe it as the throughput to a different stage. So in our example, when we had UAT, some organizations would say, what is the throughput to our UAT environment? Because there's other reasons why things don't progress to production, other business reasons. So that's one of the things that I'm going to repeat, is that your definition, how you define it, is going to be important. But generally, we're talking about the frequency of deployments to production. And we've selected this as a metric that we think is really important because it basically is, whenever you talk to anybody about doing continuous delivery, whenever somebody starts to use one of our tools, we talk about their goals, they always talk about how often they want to put software into production. And that is their biggest goal with enabling continuous delivery. It's how quickly can I do this thing that my business wants me to do. So that is the primary reason, because it's often a very orientating goal for people. And it's also very easy to understand. So it's not just technical people that understand this, but it's also other people in your organization. And that's really helpful when you're doing a transition to DevOps and continuous delivery, is to have a goal that people like product managers and senior executives can understand as well. So in this example, I'm going to use production deployment instead of some other throughput to a different point, and just show you how simple it is to calculate. So there were 8 chances for the code to progress through the pipeline in this example and get to production, and only 2 of them actually got to production. So we would call that a 25% throughput rate. The next metric that I want to talk about is cycle time, and this is a duration of time. So with throughput, we talked about the number of times something happened. Cycle time is the cumulative elapsed time that it took for that to happen. And it generally means how long did it take from a code commit for that same code to be running in a production environment. And we've selected, or I've selected, we generally recommend cycle time as an important metric because it's a key element of lean theory. And we know that continuous delivery is based around a lot of lean thinking. In fact, many people believe that if we only focused on reducing our cycle time, so reducing the time it takes to do something, our organizations would run a lot more smoothly and be a lot more productive. So in terms of continuous delivery, reducing the time from code commit to production is actually also a very motivating goal, and is very instructive in terms of how you think about improving your process. I do have a caution about cycle time, though, and I mentioned this a little bit at the beginning. A lot of these definitions, their naming can change. So you may see cycle time in the literature called lead time. I would recommend that you don't worry too much about these definitions, cycle time, lead time. Is it the lead time from when somebody came up with an idea and it went to production? Or is it from the moment that you made a commit into your source repository? Or is it from the moment that somebody in the business did a sign-off? I think the most important thing is that you define what you mean by these particular definitions and you stick to it and you make that known so that the rest of your organization is clear. I mean cycle time from code to commit to production, and we're going to call it lead time because that's what we've decided. I wouldn't worry too much about those definitions, but sure, go geek out if you really want to understand the difference between cycle time and lead time, but I'm not going to bother. So this is cycle time. Again, I said it's the elapsed cumulative duration of the time it took from the code to go into the first stage, from the commit to it being a green at the end of the cycle. So in this particular case, I have this fake timeline, and I'm basically saying that it took 3 days for this commit to go from the first stage all the way through to the end of the cycle. And I think you can see in these examples, if there weren't failures along the way, the throughput would be higher and the cycle time would also be higher, and we're going to talk about that later on. But basically that's what you're measuring, from a green to a green at the end. Our next metric is a little more pessimistic than our deployment frequency and our cycle time. This is called failure rate, and this is also measured as a percentage, and it's basically the percentages of changes that result in a failure. Generally, it's measured as a code that is in production, whether you had a service outage or some kind of failure once you get to production. So in the chart that I showed you, the table at the beginning, it had failure rate there. That's basically what it meant. If I put something into production, what is the percentage chance that that would cause a failure in the production environment? But a lot of other people, particularly at the beginning of their continuous delivery journey, will calculate this as a specific failure in a specific environment. So they'll call it a build failure. So what was our failure rate at build and test at our very first pipeline? So you know, depending on where you are in your journey, you may define it differently. And we've selected failure rate because one of the biggest things that we hear about when people are considering moving to continuous delivery is that they fear the quick and the short cycle time and the frequent deployment rate. They fear that that is at the is not balanced with the quality. So they fear that by doing things quickly and often, the quality of the software may decline. And so we add this in here to help you understand, okay, I'm doing this, you remember from the definition, I'm doing this quickly, I'm putting it into the hands of my users, but is it something that I'm doing that is sustainable? Like, am I putting things out there that are still high quality? So that will help you understand that. Are you doing it at the expense of quality or not? You shouldn't if you're doing the definition of continuous delivery, but you definitely want to make sure. So I highly recommend that you keep an eye on your failure rate. So here, again, I think it's pretty clear to see now, every time we had, this is a particular stage in our pipeline, we have a red pipeline there. That means that the software failed to get to production. In this particular example, it's the reverse of our deployment frequency. It's a very simple thing to calculate. So 75% of the time we had a failure rate. But like I said, I might only have calculated it if it got to the deployment environment, and then it may have been a lower failure rate. So again, be specific about your definition and think about what it is that's important to you. I would say something like this is more at the early stages of continuous delivery when you aren't deploying frequently. You still want to know, like, what are my opportunities to get to the production environment. So our final metric is mean time to recover, MTTR, and this basically means how long does it take for us to fix a failure? What is the duration of time that it takes for us to fix a red build in my examples? And like failure rate, this is added as a measure of the stability and the quality of your continuous delivery process. But instead of just being focused on minimizing failures, which frankly you can minimize failures by like just not doing something. So if you don't try to go to production, then you're not going to fail to go to production, so your failure rate's going to look really great. The mean time to recover sort of helps you understand, okay, when we actually do get there, do we return service very quickly? Because frankly, I think we know failures are going to happen, particularly in our environments that are before production. For sure they're going to happen. In fact, we're encouraging them to happen because that's what we're doing, right? We want to have failures so it doesn't happen when it gets to production. So your mean time to recover, though, is like, does anybody care that it's broken? Like, do I just put code into the build and test environment and I'm like, I broke it, but whatever. I don't care, somebody else will fix it. Like, that's what this metric is about, whether you care about the production environment or your development environments. It's about how long it takes you to resolve those issues. So here you can see, I think it's becoming pretty clear. I'm looking for the time it took for a specific part of the pipeline, a specific stage of the pipeline, to go from a red to a green. What is the time that it took to go from red to green? And because this is a mean, I'm looking at multiple occurrences of a red to green cycle, and I'm calculating it out as 2 days. So we suggest those 4 metrics, like I said, because they are normally pretty easy to understand and they're generally applicable to most organizations. And you may want to change the definition slightly depending on where you are in your journey, but I think I would highly encourage you to start with these 4 metrics. But if you don't want to, you want to pick something else instead, I just want to give a little bit of information about how you might do that. In fact, I want to talk about things to be careful of if you are going to select metrics that are not those 4 metrics. First of all, be wary of vanity metrics, and I'll talk a little bit more about this on the next slide, but basically these are metrics that are super easy to measure, but basically don't give you any useful information. And then also be aware of unclear metrics. So like I said, the definition of these things can be tricky, and they mean different things to different people, so be very, very clear that you know what you mean and that everybody else does. And then that's another thing is once you start measuring these things, make sure that the values of these metrics are very visible. So put them in your team rooms, create a dashboard, buy a tool that does that, I don't know, whatever it is that works for you. But there's no point measuring these things and then just storing them away and nobody else can see them. You want everybody to know it takes us 12 days to get to production from a code commit, or it took us 4 days to recover from that failure. Those things are very useful to motivate people, and especially if you're using them as goals, make them visible. And I mentioned benchmarks before, but I generally recommend that you don't try and compare these metrics across teams or even across organizations unless you really have to. Using them to benchmark yourself is different than creating some kind of competition. So please don't do that. And then you may or may not be aware of this theory called the Hawthorne effect or the observer effect. And this is the idea that people actually change their behavior once they know that they are being observed. So in these cases, you may see that people change their behavior now that they have these metrics. So think about whether that's happening in your organization. The one example that I have that I know for sure this happened, an organization that we worked with wanted to, was already measuring test coverage. And we actually found out that a whole bunch of people were creating tests without assertions, so their test coverage metric increased, but what is the, testing nothing. So think about those things. I think in the case of the 4 that I described, it's very hard to fake those. You can't do a production deployment if you didn't do a production deployment, I don't think. But definitely think about if you're picking your own, that you're not creating some kind of weird situation like that. And then finally, like I put that full massive list and it could go on and on for slides and slides. Like don't collect everything if you don't know why you're collecting it and you don't know what you're doing. It's just the kind of thing that confuses people. Like be very specific about what it is you're measuring and then stick to that. And if it doesn't work, throw it away and pick something else. But don't just measure it all and hope that you see something useful in there. I highly doubt that you will. And then one more note on vanity metrics, and I know you can't read this. This is kind of the point of this slide. So like I said, vanity metrics are things that are really easy to measure but provide no value to you. A classic example is that it's very easy to measure visitors to a website, but it's less easy to measure active users of your software. And the most important thing is, are people actually buying your product or using your product rather than just coming to your website? So that's kind of the general vanity metric example. In software, we often see that bug fixed is a vanity metric. It's quite easy to track bugs. It's quite easy to track if they're fixed or not. But do we know whether a fixed bug actually means you have higher quality software in production? Were your users more satisfied? Did they have a better experience? It's really hard to tell. So, those are the kind of things that I mean. Like, it's nice to know you tracked a bunch of bugs, but did it really make any material benefit to your organization? So think about that. Another example would be like lines of code. Like we don't want to start tracking how many lines of code somebody wrote because often that actually would lead to bloated software instead. But it's kind of easy to measure, so avoid that kind of trap. And specifically with continuous delivery, there's a trap that I would avoid if I were you. Often we see organizations using something called a maturity model to measure their success in continuous delivery. And basically what that is it's a set of tools and techniques that somebody has said, in order to do continuous delivery, you need to be able to do these specific things. And those things are generally right, like I believe most of what is there. But whether your team is actually doing those things and whether that actually means you deliver value to production more often, I don't think those are the same thing. So I would avoid using something like a maturity model, which just assesses, like, are you doing continuous integration? Do you have a unit test suite? Like, yeah, you may have a great score on the maturity model, but it's not actually measuring whether you are achieving those things we talked about with the other metrics. So my preference would be, if you want to do any measurement, pick those 4 metrics. Sure, do a maturity model as well, but I just don't think it's going to be as good to give you information about how well your continuous delivery process is going and how that journey is progressing. So finally, you've gathered your metrics, you have some values from them. What are you going to do once you have those particular metrics? You want to be able to understand what they mean about your organization. So I'm going to work through a hypothetical scenario with some values for some metrics and show you what I would do if I saw those values. So here is, this is from the product Go that I talked about. It's quite bright. You can't see it quite as well as I hoped, but these are, imagine a little box around these, like the image that I had before. Each of those little squares is a stage in a deployment pipeline, and the green is obviously a passing stage. If it were red, it would be failed, and the yellow means that that particular stage is running. So this is our test scenario, our hypothetical scenario, and it looked very like the other one. I have a build and unit test, I have some integration tests, performance tests, UAT environment, and then out into production. And in this particular scenario, I'm going to imagine that somebody in my business complained that we were not deploying to our customers as quickly as they had hoped. I want to show you how I would use those 4 metrics I talked about before to understand if that's really happening and what's actually causing that to happen. So we recommend looking at throughput, which was our deployment frequency, because obviously they've said you're not deploying, your throughput's low. So let's go take a look at whether that's the case or not. So to figure out whether low throughput is a problem, you would look at the run frequency of the part of the pipeline that you care about. So in GoCD, we can actually look at the throughput for different stages of our deployment pipeline. So if I take a look at the build and unit tests, I would be able to see a chart that showed the run every time that that particular stage had ran and the duration that it took for that to finish. The red dots there are failures again, and the green are successes. So if we focus on the run frequency, we can see that this particular stage ran 100 times over the last 30 days. And then if I look at my stage, the end stage of my pipeline, I can actually see that during that same period of time, the production pipeline actually ran less than 20 times. So I can see that clearly I've been running the start of my pipeline a lot more than I've been running the end of my pipeline. And so my deployment frequency, my opportunities to deploy were a lot higher than the times I actually did deploy. So yeah, I actually do have a low throughput throughout this cycle. And it's definitely confirmation that what the business is saying is fairly reasonable. Like my output from that pipeline is fairly low. So the main signal, the thing that we saw using those metrics and from our business telling us something is that the throughput was low. But there may be many, many reasons for a low throughput. It could be that your builds were slow running, like maybe they took forever to run to get through that pipeline. Or it may be that you use a branch-based development environment, so you have multiple different branches, and all of the work that was great was happening in a particular branch and was not in the trunk or the main line and was not going through your main deployment pipeline. Or it could be that your environments were down, or that you had problems in a particular environment. Like there are many different reasons why throughput is low. So that's why you want to have those other metrics so that you can take a look and understand like what might be happening. So let's take a look at cycle time and see whether that's going to help explain what might be happening in this particular scenario. So again, this is an image from GoCD, and one thing I want to say is like I'm using GoCD. I mean, I think it's pretty obvious. I work for ThoughtWorks, and this is the product that we use. But you can do all of this manually. I have seen teams, chalk this down on a whiteboard, or any CI tool that you're using is going to give you like build time and duration. So I do want to say like I'm using this for illustrative purposes. It's these features and functions. You can find in other ways. So anyway, in GoCD, this is our value stream map. And again, I'm going to look at the build and unit tests and see how long it took on average to move between two parts of this continuous delivery pipeline. So on this screen, what you see is each specific run. So every time that pipeline ran, from the build and unit test part to the production part. And you can actually see that there is a, oops, sorry, I went too far. I still went too far. You can see on this one that we actually have I thought it was going to highlight it. That's what happened. I have a throughput of 20% from that one stage of my pipeline to the other stage in the pipeline. I can actually drill down to see what is actually happening in that particular stage. And that's what happens here. And when you drill down, you can actually look at each part of the pipeline and see how long it took. So we can actually see the wait time, which is shown in gray, as well as actually what is the running time. So these are the stages that were in my pipeline before, and we can actually see that we have a significant amount of wait time in some of those stages. So that would explain for a slow cycle time and potentially a low throughput as well. So that's what I'm saying about these things play on top of each other. We, just seeing a low throughput, we would have not known that we were waiting for a particular environments to come up or agents to be ready to build, those kind of things. And again, you can drill in and see a lot more detail about what is specifically happening during those different stages. So in this example, I'm going to call it, and I'm going to say, okay, the low throughput was actually caused by a cycle time that was slow, and there were specific steps that were slow to complete, and that they required lots of wait time, which led to the overall low throughput. The idea here, what you would want to do if you also saw a situation like this, is you want to focus on the slowest parts of your pipeline. Those are the places where obviously you're going to make the most gain. So where are my longest wait times? Which environments am I waiting for? Am I waiting for a manual approval? Remember I said in continuous delivery, you may have parts of your pipeline that require a person to say yes. Is that where your wait time is? Often that's the case. Those are the things that you want to highlight and say, hey, our throughput's low because we waited for this environment to be up, or we waited for this particular approval to take place. Use these metrics to help you have those hard conversations about changing the way that you work. Another thing is that sometimes your test suites are just big and they just take a long time to run. Maybe you have lots of tests that are important to run. So there are a couple of different ways to manage something like that. One is split out the most important tests and run those first. So try and run your slowest running tests if those are the most important ones at the very beginning. Or run your quickest ones if they provide the most value to you. Like, think about, do I need to run all of this at this point in time, or can I get some reassurance up front and run those quickly and then put my ones that always pass, but I have to just check them towards the end of your pipeline. So basically bring the pain forward and test the hard things first. And then that actually will get you feedback quicker, and then you can then move on. The other thing is that you may want to consider parallelizing your tests. So often when you map out your continuous delivery pipeline, you'll see that there are things are not dependent on each other. You can run an integration test suite at the same time as a performance test suite, for example. So consider parallelizing your work, having things run at the same time. It will reduce your cycle time and increase your throughput. So let's take a look at failure rate now. What would happen if reduced value was actually due to a high failure rate? So in this earlier image that I showed you, it was showing many different runs of a particular part of the pipeline, and you can see that there were a lot of red dots there. There were actually a lot of failures. So looking at these parts, you would definitely say that the failure rate was actually really high. And we can actually focus in on that in GoCD, and it actually gives you a percentage failure rate. So in this case, we have a 35% failure rate, which is, I would say, pretty high. If you're looking at anything above that 15, which we talked about from our benchmarks, it's a fairly, you're not a high performer. Let's put it that way. So failure rates are going to happen, and I definitely would say that this is one of the more tricky metrics, because although you want to reduce your failure rate, as I said before, you actually want failures, because you want to fail when these things are in your control and not when it goes to the hands of your users. So do not penalize people who break a build, have high failures. Talk about the underlying cause for those particular issues. And common things that we see, I'm sure you're all familiar with, like the flaky tests, those things that just for some reason break often. Or maybe you have some tests that are just super hard to run locally. So think about whether you can split those out or use a different technique. Like, focus on the underlying issue of why those things fail, rather than the fact that you just have a failure. And again, I don't think I can repeat enough. Like, we want to reduce failure rate, but definitely don't penalize the people that are failing. I think the important thing to think about is, like, how quickly do you recover from that failure? And that's what we're going to look at now. So as you might expect, Go is able to calculate your mean time to recover from particular failures at different points of your continuous delivery pipeline. It would capture the time between a previous failure and then the next successful running of that particular part of the pipeline. So the thing I described before, that red to green cycle, it calculates that, it averages it across time, and it gives you your mean time to recover. And that's particularly important, like I said, because your failure rate might be high, but you might respond to that very quickly. I think that's a much better situation than a failure rate that's, maybe not too low, but that you just leave things broken for a long, long time. So I think these two metrics very much need to be considered like hand in hand, failure rate and mean time to recover. And often slow cycle time will turn up and actually be a failure to restore service quickly at a particular point of your pipeline. So like I said, when we had cycle time, maybe it was wait time. In my example, I said it was wait time, but it might actually be that you have these flaky failures and you don't bother fixing those failures. So effective mechanisms to combat mean time to recover that is high is basically an unquestioning reversal of things that break builds. So if you break a build, we do know organizations who will automatically revert that change and bring it back to a green state. And that's a very bold thing to do, but I would encourage you all to do that. Like, failure's fine, but we want to fix it as quickly as possible. So whoops, sorry, that code's, it's gone back, sort it out, bring it back when it's ready. Other things that you could do, a little more kind, is just stop the line. We don't want to take any more commits into this pipeline till this failure is resolved. So as I think I've shown, those 4 metrics really help you to build a complete understanding of your continuous delivery pipeline, and they really build on top of each other. So like I said, how they would encourage continuous improvement, they will also encourage continuous improvement by thinking about them one after each other. So just a quick recap before I take some questions. First of all, I talked about how metrics are important for you to set goals and improve your continuous delivery processes, and how they really help you predict your future behavior. I encourage you to think about using those 4 metrics, but if not, please be very thoughtful about what it is that you're picking. Don't go for something like a maturity model just because it's easy. Think about what it is you're actually trying to achieve. And once you gather that data, make sure you actually look at the values and you look for connections between the values of your different metrics. And the important thing is, which I didn't really draw on because it's very much dependent on you, is you have to understand your organization. You have to understand the context with which you're working in to really understand what those metrics mean. A good example of this could be that maybe you have a temporary slowdown in cycle time because you have a bunch of new developers on a particular team, or you have a product that just started up. You have to understand the context. Maybe it's not a big deal that the failure rates are high for a particular period of time because you understand why that's happening. So think about these things not just theoretically, but practically within your organization. And remember that the whole thing is about feedback. So if you don't like those metrics, they don't provide value, nobody's using them, check them out and pick some others. And consider using some tools to help you. I think it's really easy to see some of these things in GoCD. Like I said, other tools have this. Make them visible, put them in a place where people can see them, and I think you will see value from them. And I think that is it. I have some reading here. Feel free to take a picture. I can also tweet this out. It's some other reading about continuous delivery. There's also a tiny little booklet. I don't have many of them, but if you're interested in some of this, the definitions is written down in the little booklet there. And now I have a few, maybe 2-3 minutes for some questions. Hello.
Hi.
Hi.
You said fail fast. Have you seen anyone utilize measuring how long it takes any particular phase to fail, and then say hey, we want this failure metric to be lower? Because you're saying put certain tests.
Yes. Yes, for sure. I would say like we often see that people have particular parts of their pipeline that just fail a lot, and they will put concerted effort into saying like, what the hell is going on in this particular stage? And often, you know, I don't want to be too blasé about the flaky test thing, but you know, browser automation often can be the problem in those particular stages. And so we do see people actually have like a flaky test stage. I don't think I would advocate for that, but that's one way that I've seen, which is basically it's always these tests. I'm going to move them out for now, let the rest of my pipeline run, and then run them at the end because I pretty much know I'm okay. Maybe I'll manually test those features instead. So things like that for sure I've seen people do. Did that answer your question?
Kind of.
You can ask it again.
Would you want to put a specific metric around, I want these, if a test is going to fail, I want it to fail in less than X?
Oh, I think it depends on the particular, so you mean a very specific case in a very specific test?
Or at any point in the pipeline?
Yeah. Yeah, for sure. Like, especially if you think parallelization is an option for you. So if you think this whole thing is taking a long time, then you could put a metric around, I want it to take this much time instead. And that would encourage you to either split up your tests, like I said, or parallelize instead. So yes, I think I understood it now. I would definitely encourage doing that. I got the stop sign, but I'm going to take your question anyway.
Yeah, a question about throughput metric.
Yes.
It seems it's kind of the reverse of the failure rate.
Yes.
And
Yes.
I'm just thinking, why do I care so much about the percentage of failures of throughput relative to number of runs? It seems like maybe I care more about how often can I release every day. Like if I'm so why is it not just to measure how many successful deployments per day I'm able to do, and I can use failure rate more as a percentage to see how efficient my pipeline is?
You could definitely do that. And I think I just picked the ones that are the most generic versions here that are most generally applicable and the most easy to understand. But I think that you could definitely do that. So remember I said sometimes throughput is deployment frequency. And if you take a look at Nicole and Jez's work, that's the term that they use. And it is measured more like how many times do I do this in a period of time. So you can definitely do that, yeah. I think sometimes at the beginning, it's actually quite nice to just compare the throughput with the failure rate. But I think your suggestion was perfectly valid. I think I am going to wrap up now. I apologize. I thought I would have more time for questions. So.